Hello everyone, I'm Mrs. Snook with section 1.6 Inverse Functions. We're going to find inverse functions and verify that the two functions are inverses of each other, and in a moment we'll talk about what that means. We're going to use graphs of functions to decide if two functions are inverse, so for those of you who are very visual, you'll like that method. And then we're also going to find those functions algebraically. So first of all, let's talk about an inverse function. I think of a function as a vending machine. So I'm going to draw a picture. Here's our vending machine. And your input is your money. You put money in, and output is a snack. So we think of input as x and output as y. For an inverse function, it goes the other way. So here's your vending machine. Now your input is the snack, and your output is money. So what this means, when you're finding an inverse, you literally swap x and y. And if you keep that in mind, inverses are super simple. So let's do this first one. We are going to find the inverse of f of x equals 4x. And what you're going to do is, I'm going to rewrite this as y equals 4x. Now, swap the x and y. So when I do my swap, x equals 4y. So now this is my inverse over here, and I'm going to solve for the y. Divide both sides by 4. And then y equals x over 4. Now we're going to use this notation, f negative 1 of x. When you see that, that means inverse function. Does not mean reciprocal, it means inverse. So I have my original f of x is 4x. I have my inverse, f inverse of x is x over 4. Now to verify that these are inverses, what I'm going to do is I'm going to use composite functions. I'm going to plug one function into the other, and if those two are inverses, I should get what's called the identity function. That just means y equals x. So when I plug in, if I get just an x, then those are inverses. So first, let's plug the inverse into f of x. So I'm going to have f of, here goes the inverse, that's x over 4, equals 4. And then where there was an x, I put x over 4. My 4's cancel, and I get x. So that worked. Now let's go the other way. Let's plug the original function into the inverse. So now I'm going to do, using the inverse function, the original function is 4x. So now where there was an x, I put a 4x. Here's my inverse function. Those 4's cancel, and I get an x. So I have confirmed that those are inverses of each other. We're going to play the same game, but this time our function is f of x equals x minus 6. So first, let's get the inverse function. So f of x equals x minus 6. Rewrite that as y equals x minus 6. Now I'm going to swap. So when I do that here, I'm going to get x equals y minus 6. Solve for y. X plus 6 equals y. Let's flip this around, or just rewrite it. We're going to say inverse of f of x equals x plus 6. So here's my original function, here's my inverse. And now I'm going to plug them into each other to see if I get identity function coming out. So we're going to do f of the inverse. So in my original function, everywhere there was an x, I put an x plus 6. So I have x plus 6 minus 6. 6 minus 6 drop out, I get an x. Now plug the original function into your inverse. So we're going to plug x minus 6 into our inverse. So x minus 6, that's the inverse. And then there's a plus 6 on the end. Those drop out. and I get x. Those are inverses. Okay, now we're going to find them algebraically. Play the same game. Where there was a y, put in an x. Where there was an x, put in a y. So I'm going to do f of x is 2x cubed minus 1. Rewrite that as y equals 2x cubed minus 1. Swap. So x equals 2y cubed minus 1. So here's the swap. This happened here. Solve for y. So x plus 1 equals 2y cubed. Divide everything by 2. That gives me y cubed equals x plus 1 over 2. Take the cube root of both sides. So now my inverse of x equals the cube root x plus 1 over 2. Now compare that with g of x. It's x plus 1 over 2. So I'm pretty sure that when I do the inverse of g of x, I'm going to get the f of x. So let's try that one. So now let's invert g of x. I'm going to say y equals cube root x plus 1 over 2. Swap the x and the y. So now x equals cube root of y plus 1 over 2. Now I want to get the y outside of that cube root. So I'm going to go ahead and I'm going to cube both sides. So I'm going to say x cubed equals y plus 1 over 2. Now this is pretty simple at this point. Multiply both sides by 2. I get 2x cubed equals y plus 1. Now subtract 1 from both sides. I get y equals 2x cubed minus 1. Going back into function notation, the inverse function of g of x is 2x cubed minus 1. And look at that! They match. All right, which of the functions g or h is the inverse of f? So here's what I'm going to do here. I'm going to just find the inverse of f of x, and then I'm going to compare and see which one it is. All right, rewrite as y equals 5 over x minus 2. Let's swap x and y. So here's the swap. X equals 5 over y minus 2. Now we're going to solve for y. And what I have to do, because y is in the denominator, is I'm going to multiply both sides by y minus 2. Those are going to cancel. I'm running out of room, so I'm coming over here. So I get x times y minus 2 equals 5. Divide both sides by x, because I'm trying to solve for y. Y minus 2 equals 5 over x. And then I need to add 2 to both sides. Y equals 5 over x plus 2. And our answer is H. All right, now the next thing we're going to do is we're going to verify graphically that our functions are inverses of each other. These are the same ones that we did algebraically, so we already know that they should be inverses. Now, when I graph two functions, I know they're inverses if they reflect over y equals x. So what I'm looking for is symmetry over y equals x. So the easiest way to do that is to graph both of your functions and then also graph y equals x. That will give me my symmetry line to look at. So let's grab our calculators. Here they go. And our first one we're graphing is going to be 2x cubed minus 1. So 2x cubed. Oh, I don't want a minus 1 there. So arrow over, put my 3 in, put my cube in, and then I'm going to hit the arrow and minus 1. That's our first graph. Our second one is going to be cube root. Here's how you get to cube root. I'm going to press the math button, and right here at number 4 is cube root. So hit enter. Now I've got cube root, and what was it? X plus 1 over 2. I want to make sure x plus 1 stays in the numerator, so I'm going to use parentheses. X plus 1. Close those parentheses, and then we're going to do a divide, and then 2. And then the third one I want is just y equals x. So the blue is f of x, the red is g of x, and then the black one is going to be the line of symmetry. See that? It's reflecting over the y equals x. So when you see symmetry on both sides of that, that says that you've got inverses. All right, the next thing we're going to do is we're going to verify our functions numerically. So now we're looking at the tables, we're looking at points. And if they're inverses, then the x of one function is going to be the y of the other one, and vice versa. So what I'm going to do is I'm going to graph f of x, x minus y over 2. All right, so we're going to verify these functions numerically using the tables on our calculator. So I'm going to do f of x here, and I'm going to do g of x here. Now for f of x, I'm going to graph that on my calculator, and I'm just going to write down the xy table that I get. So grabbing my calculator, just clearing all that out. First thing I want to graph is x minus 5 over 2. So x minus 5 over 2. Let's graph that. So I have a line. Let's open the table. And what I'm going to do is I'm going to select points that are whole numbers. So I have 1, negative 2. And I'm going to grab 3, negative 1, 5, 0. Now let's get 2 more. And 7, 1, and 9, 2. Now since these are inverses, the x and y's should swap. So I'm going to copy the y's from my table, so these here, and I'm going to use them as the x's. So negative 2, negative 1, 0, 1, 2. So now what I'm going to do is I'm going to graph the g of x on my calculator, and then I'm going to look up the values on the table for these x values I've selected. So we're going to go to y equals, we're going to clear and clear, and we're going to graph 2x plus 5. So 2x plus 5, let's graph that, and then we'll open the table. Here's my table, and I want to use for my x values negative 2, negative 1, 0, 1, and 2. So I need to scroll up a little bit. Negative 2 is 1, negative 1 is 3, so I have a 1, 3, 5, 7, 9. So now when I compare my tables, I can see that the y's are matching the x, And then look at my original x's. They should match the new y's, and they do. So now I have verified that those two are inverses numerically. Algebraically, find the inverse of this function. Just rewrite as y equals and then swap x and y. So I'm going to write down our steps. Y equals to swap x and y, and 3 solve for the new y. So y equals 5 minus 3x over 2. Here's the swap. X equals 5 minus 3y over 2. Solve for the new y. 2x equals 5 minus 3y. 2x minus 5 equals negative 3y. So then y equals 2x minus 5 over negative 3. So now my inverse function is 2x minus 5 over negative 3. We're going to find the inverse function of this one algebraically. Now we've got an x cubed minus 4. Follow the same steps. Y equals x cubed minus 4. Swap. X equals y cubed minus 4. Solve for the new y. And then we're going to cube root both sides, which means my inverse function is the cube root of x plus 4. Last one. Try to do this one on your own. So pause the video, find the inverse of f of x, and then compare your answer with mine. Okay, here you go. This is the work that I did. Rewrote it as y, and then swapped x and y. I solved for y, and I got inverse of x is x squared plus 3 all over 2. You may have written it like this, which is fine. You may have written x squared over 2 plus 3 over 2. That works as well. You may have written 1/2 of x squared plus 3. That also works. Those three forms are all the same. All right, so that's it for today's video. Thank you for watching. Have a great day.